Yeah, hi, this is Carol in Msinje, Computer Science, Year 1, and I'm here to present Computer Vision Assignment 1. Yeah, we start by edge detection as one of the principles in computer vision. Edge detection is an abrupt change in intensity, like that change where there is a change in either brightness or contrast. That's what is referred as what between the two regions. That's what is referred as edge detection. Yeah, like it can be either like a sharp variation in color, it can be a difference in maybe intensity. That's really edge detection. Yeah, so steps for edge detection. Step number 1, we have pre-processing, whereby an image is prepared, normalized. This is a process whereby you prepare an image depending on the desired format. Yeah. Then we have feature extraction. Feature extraction is all about like extracting important features, talk of corners, talk of edges from an image. Then we have another process, which is the training. The training is more concerned with training models that are labeled. Yeah, we use supervised learning mechanisms, so we can for machine learning, for neural networks. Then we have object localization. This is all about like identifying regions of interest where the objects may be present using techniques like maybe sliding windows or region proposal networks. We have classification. Classification is more of like categorizing an object. For example, you can have various kinds of objects within the scene. You can have cars, you can have people, you can have street lights, you can have trees. So with classification, each object is classified basing on its. Yeah, so we have got even the algorithms for edge detection. As a edge detection is a fundamental technique in computer vision that is used in identifying boundaries within images. And of course, there are algorithms along that help us in edge detection. The first algorithm, we have the one called pre-width edge detection. This is more of an operator, but it's more of gradient-based detection that uses like the boundaries. It uses two kernels, that's the X and the Y. It actually uses a 3 by 3 convolutional kernels to detect images. Like you can see, the GX will detect edges within the vertical, then the GY within the horizontal direction. That's the pre-width edge detector. Yeah. Then we have Sobel edge detector. Yeah, as Sobel edge detection algorithm, it also works by running a matrix, call it a 3 by 3 matrix. That is maybe a kernel over the pixels within an image. At every iteration that is made, it uses a matrix of 3 by 3. We measure the change in the gradient of the pixels that fall within the kernel. That is the 3 by 3 matrix I just talked about. So it also uses the two known filters. That's the gradient in X direction, call it the vertical, and the GY, that's the gradient in the Y direction. And then each gradient is a product to what? To an image pixel. Like an image in a computer is stored as what? As numbers, or call them pixels. Then we have Lipschitz edge detection. Yeah, this one uses only one filter, so it uses only one kernel for edge detection. It's actually referred to as a single pass. It performs second order derivatives, and meaning it is more sensitive to noise. Yeah. It is more sensitive to noise, and in a sense that it applies Gaussian smoothing to avoid noise. It tries hard to first do the Gaussian smoothing, and Gaussian smoothing is more of an algorithm is used to calm down the noise within the image detection. So the most two filters used, we have this one that has a 4 and a 9. Yeah, those are the most filters that are used, but one is used at a time with the detection. Yeah, then we have the kernel edge detection. Kernel edge detection, it is actually one of the most popular edge detection methods in use today. Yeah, because it's robust and flexible. It follows a 3-stage process in extracting edges from an image. Yeah, so we have the noise reduction. Yeah, it does more of like smoothing. And then the next step is calculating the intensity of the gradient of the image. And then it tries to suppress the false edges so that it's a bit more robust, like I told you, and flexible. So it tries hard to suppress or to eliminate the false edges. So we have the iterative thresholding as the fourth step. This is more like locating a threshold of what is the maximum edge detection that maybe it can go up to. This one varies depending on. So then we go to this corner algorithm or corner detection. First and foremost, what's a corner? A corner is defined as an intersection of two edges, like the point where two edges meet, or the point where the intensity of the image changes abruptly, like we said, that's an edge. So at that point where the 2 points meet, that's a corner, where the gradient or intensity changes, where there is a change in edge, that's a corner. So we have corner detection. It's also like a technique or a fundamental technique in computer vision that is used to identify the presence of corners or junctions in an image. Like corner detection is that process you go through to identify the presence of corners within an image. So there are actually various roles in computer vision. Yeah. Roles of corner detection in computer vision. We have robotics and navigation. Yeah, corner detection is used for localization and mapping and avoiding obstacles in robots. Since we try avoiding the collision by detecting what the junction between the edges. Then we have it is also used in feature matching. Yeah, it's used for tasks like image alignment, object recognition, and image stitching. We should bear it in mind that corner detection is one of the feature extraction mechanisms in computer vision. So when we talk of feature matching, it is one of the key elements we can't do without. So we have object detection and recognition. Through corner detection, we can highly detect given objects and recognize them based on what? On the nature of the scene and the corners. So corners are also used corner detection is used in motion tracking. that is like tracking objects in motion or in video analysis and survival. Yeah, we have even, it's also used in calibration, in camera calibration. Yeah, so it determines like camera parameters in 3D reconstruction and in virtual reality. So corner detection is as well used in image compression, since it improves the compression efficiency and then preserves important image features. Bear it in mind again that corner detection is one of the feature extraction mechanisms in computer vision. So it is also used in quality inspection, since it is used in detecting detecting in what? In manufacturing and other industries. So now another question lies: how does corner detection work? Corner detection works on a principle. For example, you press a small window over an image. So if that window flips in any direction, there will be a large intensity, because that will be a reason for the window changing or flipping. And if it does not flip, obviously that means there is no intensity or change within the gradient, so there is no corner, as there is and the first corner mechanism. So like I told you, applications of corner detection: image registration, 3D construction, object recognition, and augmented. Product of beta, we are going to substitute, because remember, yeah, meaning that our overall answer will be alpha equals beta times sine beta plus theta, where beta is the magnitude of the sine wave and alpha is the phase. So the question here lies: why do we parameterize the lines? Yeah, the only answer we can give, if we do parameterize the line in slope intercept from the accumulator arrays, it becomes very large. Yeah, in a sense that the range of the slope can be from negative to infinity or to positive, and hence there is no bound on the accumulator array, hence minimizing the errors. Additionally, since a slope of a straight vertical line is infinity, yeah, we all know that the slope of the straight vertical line can be infinity in a way that it cannot be represented in a slope intercept from the vertical lines, which gives the rise to unbound values in the parameter space. So those are basically the two reasons as to why we parameterize. So we have another question which was stating: assuming that image points x, y are in images of width w and height x, that is x summation of I w, y summation of I h, what is the maximum absolute value of alpha, and these points that we are required to plot: 10 10, 20 20, 30 30. I actually tried plotting them using matplotlib in Python. Curves appeared. This is where the intersection was. A question which required me to use a filtering function to filter a given image. Yes, so first and foremost, I have to install CV2 for image processing in Python, and I used the NumPy package since my image was to be represented as an array, as a NumPy array. That's why I had to import NumPy. Then matplotlib was basically for plotting, for plotting the image. So when define my image filter, I was trying to define my function which you had parameters of the given image and the NumPy array. So the image 1 was filtered through 1 and H, and the image 1 still, I had to first use the NumPy to clip the image to some integers, like to give it a range of 0 to 255. Yeah, so after flipping it, I had to return the image. So here I'm trying to plot my image. So render image, this is a variable that is going to store the plotted image, CV2. So imread, it's a function that reads a given image. In fact, this image had to be converted first to be a grayscale image using the filter. This is the kernel, the kernel filter, a 3x3 kernel, a convolution filter which is a 3x3 matrix. So after applying the filter onto a grayscale image, I plotted, and that's how my image came up with. This is a convolved image or a filtered image. We have some principles here still for edge detection. I was required to code or to show how an image will appear after applying it on a filter to detect image, So again, like I told you, I had to import CV2 as a package for image processing in Python, NumPy, for representing images as arrays, then matplotlib for plotting. So the same stuff I applied in filtering the image. In filtering the image, so image X, I had to use a Sobel filter, which is the gradient X, which filters image in X direction. Then image Y, I had to use the Sobel Y filter. Those are the, like I told you behind, those are the filters or operators used in image filtering. So that's how I was able to load my image and detect images. I had again to put it in grayscale, like you are seeing here, matplotlib for showing and displaying the then the edge detected image appeared like this. So still there was this requirement of transforming the image. So still I had to import CV2 as a Python as a package for image processing in Python, NumPy for reading the arrays or image in arrays, matplotlib for plotting. So the image was also converted to, I had to load the image, like you can see. Then I set my lines. Those are the half lines or edge image, lines 1 to 80. So the lines through the image by using the function. So that is it. I had to plot again using what? That's how my image appeared, with the line hopping through. Thank you. That's the end of my presentation. Thank you so much. I remain Carlo, Masters in Computer Science, Data Science option. Yeah.